Sudarshan Sivaperumal, Security Solutions Architect from FI Networks, as the speaker for today, and he would be discussing how organizations can secure their API services. You can post your questions in the chat box throughout the presentation. Sudarshan would respond to them post the presentation. Over to you, Sudarshan.
Hi, thank you, Rahul, and thanks everyone for taking time out. It's month end and it's busy both in the enterprises and with the partner community across organizations. So thanks for taking your time out for this webinar. So what we are going to do in this webinar quickly is, yes, I just wanted to have a quick run on the overview of what APIs are. How do we see APIs being vulnerable or getting vulnerable? What is it that's required to protect the API services, and how does F5 come into play with that? And finally, we will have Q&A. So all of you would be in the would be muted by default. So towards the end, we will open up for questions. You can have the Q&A window out there. You can type your questions. If I'm not able to answer that due to time constraints or so, we will get back to you on a one-on-one basis for the questions. With that said, let's get started with the overview on API. So Rahul, my presentation slides, can you see that? Right, no problems, just checking. All right, I would assume that you're able to see all the slides. All right, so what has happened is apps have fundamentally got changed, right? Way back when I started programming a few years before this, in 98, 99 timeframe when I started the career, the apps were very kind of monolithic in nature, right? I mean, we used to still develop it as a web app database layer. Each app used to have that same layer, kind of monolithic, single cluster, kind of hosted out of one single data center. And rarely the apps were kind of getting refreshed. I mean, refresh used to happen once in a while. I mean, probably in a life cycle of a year or so before any change would happen to it, and not so drastically. Even websites were pretty static in nature at that kind of time. Now come 2018, fast forward 2018 is where we are looking at very, very user experience is key, and we are seeing how applications can can interact with the users much faster. We are talking about CI/CD, continuous integration, continuous development pipeline, which means there are hundreds, if not thousands, of pushes or changes made to the application as it is in production. We are seeing that it is hosted across data centers and hosted across in a hybrid nature within data center, public clouds, and so on. And one of the most important point out there is we see how these applications are interacting very closely with each other, right? You see them, each of them being loosely coupled, but they kind of interact with each other, right? Kind of in another way to represent is where this is the old monolithic format and kind of move to an microservices kind of an architecture where everything within that application, as a user, we see that as one single application, but on the back end, it's actually multiple microservices that's actually giving us that feel of one single experience. You take Uber today, you take the Swiggy today, you take Olas, and you take all of these modern applications, they're all built on the microservices platforms. And during the interaction, we see even banks, fintechs actually are one of the other innovators in this field who are actually moving to a very microservices architecture, e-commerce industries. We see that in a lot of telco applications, not the core telco, but the telco applications or service provider applications which are being used for end user consumption, right? Those are all moving towards this kind of a microservices architecture. And where in this microservices, when we are talking of loosely coupled, is where we are talking about this microservices being loosely coupled, but they kind of talk not the east in the typical north-south kind of interaction with the databases out there, but they talk east-west between these microservices as well. And what's happening is apps are driving the changes today, literally, right? I mean, apps have kind of changed the way how business have actually transformed. A lot of things recently, from the Uber, Ola to Netflix to Swiggy's and so on, how they have changed the business model of a particular, or the model of a particular business. And most of these are done with APIs. Okay, so what is an API, right? So an API is what we call as an application programming interface or a programmable interface. Typically, the advantages of that, it makes the application very lean and agile, right? Which means that it doesn't have that kind of interfaces to which you can send a request, you get a response. The request and the response are very lean in nature, which means it doesn't add too much of overhead in terms of payload to actually do that. Being agile is where it actually helps in the CI/CD pipeline development, which is why the DevOps, and in today's world, the modern applications are actually use the DevOps way or the agile way of building it. And the deployment method is no longer anything constrained with the hardware. They are more moving towards the containerized form of the applications. And APIs really gel very well with that and kind of make these applications going much faster, support the agile model of it, make it much easier in terms of microservices, architecture, and so on. At a high level, I mean, what we generally, and this is no industry terminology or anything, this is what we put from our experience that we've seen in F5, is that typically customers who actually have API services or interact with the API services, very high level classifications you can do is, okay, there are some internal APIs that are going to be used for east-west kind of a traffic within the internal applications. There are external APIs which are opened out to the external world to be actually consumed. You can take examples of the LinkedIn's and the Google APIs of the world, which are actually hosted by Google or LinkedIn and so on, but they are actually for external public consumption. And there are actually partner APIs, which is where we see things, organizations which have business partners. So if I'm a bank and I have maybe my a partner who's actually servicing credit cards for me, or who is actually helping me sell credit cards, they have exposure to certain APIs where they can pull certain amount of information, maybe on the customer and so on or so forth. If I'm a bank and I'm tying up with probably dining partners or cab companies and so on, I might want to expose certain APIs to them. So there are partner APIs, which could be, which is probably with a trusted partners that you would want to share some kind of an information, or in many cases receive some kind of an information. There are API calls like where you go to a movie or you go to a hotel, and then you have an ability to actually go to TripAdvisor and actually make a comment on what kind of, or your feedback services that can then be attached to the hotel through, or the aggregator through which you booked. So there could be links within those trusted communities where data can even be pushed into your application or pulled by the partner, business partner. As I was saying, APIs are moved into all sectors. Fintechs are there, financial services out there. We see service providers, we see governments, and you might wonder governments, and a lot of the governments. I mean, smart city is one classic example when it actually comes in full blown, where we will be using a lot of community services or a lot of government services through mobile apps and so on, and then one app talking to another, getting authenticated, trying to pull information from the others and so on. All that could be on APIs. Healthcare is another industry, e-commerce, hospitality industries, you name it, pretty much every industry is moving on to the use of APIs to make their applications much better user experience for the end users, making it lean and agile so that it can be developed in a microservices platform and an architecture, making it such that microservices architecture helps them to develop new features rapidly and kind of enhance the services or expand their services as well, right? This is a classic example. This is of sample banking. So typically, a banking, typically you think of where okay, your fund transfer or whatever, right? That used to be one investment. All this used to be monolithic architecture. That is one big applications. You can think of it like the core banking application kind of a thing that used to be there, and then all of that used to be built into one big applications. And now what you have is you have a way where these are actually decoupled and they become microservices in nature, where each one of them is a service. So maybe out of all this, maybe the user database or the in terms of the user information is actually a small application or a microservice in itself. You can query it and say, hey, I want to look up Sudarshan's mobile number. It just responds back and gives you that mobile number, right? You say that, okay, you give a mobile number and say, okay, which are the accounts related to it, right? You get that kind of an information. You give something account number and you get what is the balance within that. So those kind of things where you do very small kind of request response over APIs, and the APIs are then getting exposed depending on whether it is internal, external, or it has to be partner. Now these applications communicate not south and east-west traffic between them, where they share information or pull information from each other, right? And what's beauty of this is that all the different, whether it is an app-to-app communication, whether it's a user interacting with that application, or it's an some kind of an external application interacting with this, all of them have one single interface, right? That means you have single URI. You could be, say, get balance kind of an URI, and that URI, when you are logging into your web banking or internet banking, you use still the same URI, or the request is made to the same URI. You can use your mobile app, it's still the same. It can be an app, whether it's an external app that is actually querying, it still is the same API URI to which this request is being made. Now, what's the problem? The problem is we have seen a lot of API abuses. We have seen a lot of attacks happen through the APIs that are exposed. And Gartner predicts that by 2022, when most of the applications started are built around this microservices architecture and the use of APIs, API abuses will become the most frequent attack vector, and which could result in the data breaches, obviously, right? So how are APIs vulnerable? So let's see it with some example. So let's say this is a typical one. This is something that we built internally, so as a modern application. So you have something which is a web application, a web interface. You probably go in and you are able to search for a particular item. In this case, it's kind of a Swiggy kind of an application where you actually search for what is the restaurants that are available in a particular zip code. So here I put a zip code number 75005, and that returns me. And this is in kind of a little this thing, but a snapshot of what the actual request goes. So it's actually making a post to a particular API URI with a content saying that, hey, look, can you give me what is the products available within zip code? Typically, you would get a response like this. These are all taken in the browser, right? I'm taking the dumps in the browser so that you can see exactly what is happening and not the nice GUI, because the GUI will not tell all of this. So here I get the list of all the products that are available. Maybe they have an ID, they have an image of the product, who the vendor is, what the SKU is, and the zip code that it is available in. So this is typically what users would do. So this could be anything. You can extrapolate it to any particular application. But now there are attacks possible, which is called as NoSQL injection kind of attacks, where instead of putting something like just the number, which is a zip code 7005, I can probably put, hey, give me everything that is not equal to 70005, right? And that would be interpreted, or this is the actual response request that would actually go in. And now if you see, I'm getting all the products that are not available in 75005 zip code. Right, and the same thing could be extrapolated to any kind of an API call where you could actually do NoSQL injection. That is, you inject something which is then actually sent to what is called as the non-SQL databases like MongoDB and the others, and they would actually process that non-SQL code, which is like not equal to, less than, greater than, and so on, and can actually throw up the response. It's poor design of the application as well, and that's how the 12box application was built, with vulnerabilities in it. But this is what could happen with over an API call to these applications. Privilege escalations, because when you see most of the time when you do API calls, you see that a lot of information, and mostly today, a lot of APIs are built using JSON. Right, so you will see kind of a JSON payload like this, where username or whatever it could be, not exactly the password in clear text, but maybe things like role. What is the role of that particular user, or maybe a group that the user belongs to, or some kind of information that could go. And what you could do is where that before that is being sent, if you know exactly how the application is going to treat the information, or is going to use some of those parameters in the JSON, you could go and you can manipulate them. And this could be something where you escalate your role, you do things like what is shown previously, like NoSQL injections to it, and so on. And you could get to information that you're not supposed to get to. Cross-site scriptings, even you could actually do cross-site scriptings where APIs now, a lot of, you would have seen in India, we do a lot of things, which is like maybe on a particular car application like Zoom Car and other things, you actually upload your copy or photo of your driving license into it. Right? If you actually gone through to rent a car and so on, you actually do those kind of things. You upload photos of into applications where you buy prescription medicines. You have to take a snapshot of the prescription and then send it to the upload it over that. And if you actually look at it, those are normally API URLs to which you actually do some kind of an upload. When you do uploads, yes, there is a possibility where you can actually inject cross-site scripts into those along with the image that you're actually uploading to. Right? Insecure APIs, and this happened at RSA. What better location to happen then? But it was an RSA, and what they used is they used APIs, unsecured APIs, which were hard-coded with hard-coded credentials into the mobile app. So someone actually decoded the app, saw that there is a hard-coded credential out there, used that, exposed it, got all the list of all the attendees' personal details who were all attending the RSA conference. You have certain examples where this was actually from a company that actually used you have connected cars today, which means that you have cars that actually talk back to the manufacturer and kind of give all different kind of details. When is my next servicing due? How much kilometers have I actually run? How is my air conditioning performing? How is my engine performing? All that stats. So all this happens over where that either the information is pushed to a particular API, or from the manufacturer can actually do an API call and pull certain kind of information back from this. And here was a classic case of one particular such vendor manufacturer. We use this API calls, but no authentication. So all I needed to know was what was the vehicle registration number. And if I could know that and I could actually do that, I could connect to it and I could pull those kind of informations out. So in summary, APIs, when they are built, they are nothing else, but they are actually developers building those API interfaces for use. And they are like any other web application vulnerable. And they are vulnerable to NoSQL or all kind of injection attacks. It could be command injections. It could be file injections. It could be any kind of injection attack that happens for data that is going to be pushed to the application. Cross-site scriptings, like web applications, cross-site scriptings are also possible. Tampering of parameters that are getting posted to the applications, that could be tampered with, and you could get access to data that you're not supposed to. You can have privilege escalation attacks. You can have all kind of authentication mechanism vulnerabilities around, from ranging from no authentications to a weak authentication format, hard-coded credentials into the APIs and other things. All kind of OWASP opt-in attacks that we are talking, testing a few, and applications could be vulnerable to them. depending on how they are actually written. And there are a lot of automated attacks. Skewing, for example, there could be an URI where API call, which I could keep hitting, that could actually generate more number of likes for a particular hotel or movie or whatever you say, or a food chain or whatever, and it could skew the results for it. I could try credential stuffing attacks through API calls to see if I get authenticated with a leaked authentication database. I could use that to actually fingerprint the backend application. Because at the end of the day, it's actually running on HTTP. I could use the API call to fingerprint what kind of platform it's being developed on, what's the infrastructure that is being used to host that particular application. Not only that, because it's at the end of the day, there is a payload that is being sent. There are worries around how that data is safe. Is it HTTPS traffic over SSL as the form of encryption, or should the data inside the payload also be encrypted and other things? API calls, again, are on TCP, so which means that it is prone to denial of service attacks all the way from layer 4 to layer 7. Data leakages, as we've seen, a lot of data can actually be responded in the response of the API query. So you can have data leakages, data leakage problems. Bots, how do you, because we have API URIs are being exposed, is the same URI that is being used by the mobile app, it's being used on the web, it's being used by application to application. So how do I prevent bots coming and consuming those APIs, and how can I protect the applications from automated attacks from the bots? So now, why does the traditional model doesn't help? The traditional model that we always do is, okay, I have an application, let me put a firewall in front of the application. Let me put a web application firewall in front of the application. Let me put an authentication gateway in front of the application. Let me put an API gateway in front of the application. Let me put a web application firewall in front of the application. So you start building this daisy chain of it, where all these kind of security services that you have, you're going to put that in front of every API service that you have. And that doesn't work, because the whole way of, or the whole premise of building these APIs, if you recollect earlier, was actually trying to be lean and agile. But if I wanted to be lean and agile, and I want to put that same traditional model of daisy chain of building all of this in front of the putting a firewall, putting a DDoS protection, putting all of this in front of it, it kind of can't scale, and it kind of goes back to where APIs will not give the business benefit or the agility and the leanness that it was expected out of. So how do you start protecting these API services, or how can that be simplified with the F5 services? So before we go there, some of the key requirements for the APIs, where in a summary, and this is not all. For example, you can see that visibility is not out there, reporting is not out there. So that's given and taken. But some of the main basic or the key requirements that every customer comes and asks is, how can I do protection or protect my APIs from being all kind of the web attacks that we spoke about, the NoSQL injections, the cross-site scriptings, the data leakages, the automated attacks, privilege escalations, parameter tamperings, OWASP top 10. So all this kind of attacks, how can I prevent my API services from not being attacked, right? Second is the authentication, right? I mean, to access the APIs, you need a very strong authentication. So what is it that that the solution can build so that it can take care of the strong authentication? One of the main things that we always look for in APIs that customers have come back is rate limiting. Since you've seen those type of APIs, internal APIs, externals, and partners. Now, I don't want to have a limitation on my internal. Maybe my internal applications should actually be able to query them. But what about my external APIs, right? Like, say, for example, LinkedIn. You can go and use an API on LinkedIn, but it only limits you to use only certain number of lookups through the API. right? Only that much is free. After that, you probably want to monetize your APIs, right? This could be for any business model. You probably want to expose your external APIs, but you want to rate limit. You probably might have different types of business partners, a gold partner, a silver partner, a platinum partner, and so on. And you might say that, hey, if you're a partner at this tier, I'm going to only give you this many API calls per hour, per minute, per second, or whatever it is. If you are my silver partner or a gold partner or platinum partner, I can increase the number of API calls that you can do into my applications and so on. So you want features where you could actually rate limit that. You want a solution which is highly programmable, so that because APIs, as they develop, we have seen that the developers actually develop they think of innovative ways of developing this, right? So you want a solution that can actually adapt to it, some new way of exposing or a new requirement that comes in. You want the solution that you're buying to be highly programmable and to be flexible to actually support that kind of environment. Performance, one of the key reasons is whatever solution you put in front of it, to ensure that you get the agility in terms of the agility of the application. You need that the solution that is giving you all this is actually helping you and deliver the services much faster and doesn't have too much of overheads. And finally, to be very cost effective in nature. So let's talk about each one of them. Securing the payload. When you want to protect the applications against the attack, it's all about how can I secure the payload that is to the application. So here is where F5 comes in, where F5 security solution looks at all the OWASP top 10 kind of attacks that could possibly go through. So we have signatures which are based for NoSQL injection. So the attack that I showed you earlier, which was with a not equal to so-and-so, you just put a signature for it. With the modern databases or the NoSQL databases, we have a set of NoSQL database signatures like SQL injection signatures. You just apply that and those attacks are gone. So no one could actually do those kind of attacks to it. Cross-site scripting attacks. We have signatures out of the box for preventing cross-site scripting attacks. All this is done because we are able to do payload validation, which means that if you tell F5 saying that, hey, you know what, this particular URI that API URI that I have is actually taking JSON payload, F5 can dynamically learn that particular URI, and F5 will tell, hey, you know what, on this particular API URI, you are actually someone is actually posting, or this API, I have learned that there are 5 different fields that are actually getting posted, and here are the values of these. So I see that there is a value or a field called username, and the value of this is alphabet. I see something which is called as a phone number, and that's actually mobile number, and that's actually 10 numbers in that particular. So it can actually have this validation of the payload that is being done, and each of the payload, it can actually look for things like tampering of it, look for attacks within that, look for injection attacks within that, cross-site scriptings, and so on within that entire payload, right? That's how we secure the applications against different types of attacks that could actually go through that API call. Secondly, the authentication part of it and the identity part of it. How do we authenticate, authorize, and can implement even something like the zero trust model? Now, this is where just a quick overrun on OAuth, because that's something that we see. There are different ways to actually authenticate the users, but we see that as modern applications, as I was saying, they are using JSON as the JSON payload is what is mostly used in the modern API calls. Similarly, we see that OAuth is what is being used as a framework for authenticating. So how does this work, right? You typically have 4 entities in an OAuth model. You have the user, you have the application, you have, which is the authorization server, and then you have something which is called as the resource server, right? So typically a user would actually request or access the application. The application would actually ask for or challenge the user for providing the credentials. So think of it in this case, something where which is actually a mobile application on your mobile device. So the user is actually clicking on that particular applications, and then the application is going to either ask for a PIN, fingerprint, a passcode, or whatever, so that the user can actually log into the applications. Once that's done, the application on behalf of the user will probably go to an authorization server and request for a token to go and access the actual application that is going to send to connect to the actual application. So when it's requested, the authorization server would then grant a token to this particular application. The application would then take that token and go to the resource server that is sitting in front of the actual application that is actually the user is going to interact with, which is, think of it, it's the Facebook application, and the application right here is actually the Facebook mobile app out there. So the requested data is the application is going to send the request along with the token. The resource server is going to take that token, go back to the authorization server, go and validate that token. If the validity of the token is valid, it's then probably going to send the data back to the application or to the user via the mobile application. This is typically a small gist of what would happen in a typical OAuth and the different entities that are there within that. Now with F5, we support OAuth as an authentication framework out of the box. We support job tokens or issuance of job tokens itself. So you can have F5 act as a resource server sitting in front of the application. You can have F5 act as the authorization server as well. You can have F5 even act as the application or the client if it is binded with it. So you can have F5 kind of offload the authentication part of it to the application, or you can offload the authentication to the F5 with its authentication services built into it. Now, as I said, job tokens is not this is not the only way. So you've seen customers who want to make use of what is called as opaque tokens, which is proprietary formats that they want to build, which is of 32 random characters. They could use it. It could be an encrypted format of it, whatever it is. So if needed, F5 can support the authorization token, in form of opaque tokens as well. Now here is where the programmability comes into play, because here F5, if the developer wants that some kind of a validation of the token before it hits the application, yes, on the F5 you could use the programmability on the F5 and say, oh, you know what, this is the 32 random characters, but maybe the first 5 or 6 of them signify some kind of a user code or a user ID or something like that. The next of it is actually something else. The part after that is so on. So you could decode that and you can say, okay, if I validate the first 5 of it, and then based on that, maybe do traffic steering, do the authentication, do restriction of the API calls, and so on. And F5 could actually help that as well. Next is the feature of rate limiting. So it could be rate limiting the number of requests from a particular client. It could be limiting the traffic from bots. It could be limiting traffic that could actually that is actually an L7 denial of service to the application. So here is where F5's broad protection features come into play. And what we have seen is that we've seen the bot traffic has kind of significantly surpassed the human traffic. That is, nearly 50% of the traffic to any application today is actually coming from bots. And the biggest problem is, how do we differentiate between the good and the bad bots? So F5 has different ways of giving the or doing the bot protection. It could be where we could use the device fingerprinting features, where if it's a web application or if it's a mobile application, we could fingerprint that device, and so that we ensure that only traffic from those devices or those ones that's authenticated, we fingerprint the device, and then only those devices can be allowed. You can use the F5 to do protection against any kind of volumetric DDoS attacks. You could do the commonly used ways of doing client-side checks and so on, but there's a catch there, right? whatever we use to do the client-side check, that works well for APIs that are made through the browsers, which could respond back to JavaScript, but it doesn't work for mobile applications. That's where the Antibot mobile SDK comes into play. So you could actually have, if you're going to use mobile apps that are going to make API calls, you could use the F5's Antibot mobile SDK, fuse your existing application with the F5's SDK. And what that does is, once you fuse the application with F5's mobile SDK, that helps saying that it can validate the client who it is. So you would know that is the request coming, the API call being made from a mobile app that is fused with my official SDK. You can see that is it the mobile app is actually running on a mobile endpoint or not, or is it running on an emulator, right? You could actually make those checks to see if there is actually a human behind it, saying where checks like, okay, mobile swipes across the mobile phone, use of the mobile keyboard, and so on. So using that, you can see whether there is actually a human behind that particular mobile application, and whether the traffic is coming from or is it coming from any particular bot. DOS protection. So the denial of service protection, F5 has machine learning features on it, which kind of baselines the traffic. And then when there is any kind of, and it continuously looks at what we call as the stress on the application, like what is the number of calls that is being made, how is the response coming from your API services, is there a degradation in the time of performance of those services, is there any kind of response code, like is it creating internal errors on your API calls and so on. So it looks at what could actually, what kind of traffic or what pattern of traffic is actually causing that stress on the backend server. Immediately as it sees this, it creates dynamic signatures for that very specific pattern. It could be coming from a particular source of IP, it could be coming from a particular browser or a version of the browser, or from a specific geolocation and so on, going to a specific URL, maybe from a referrer. So you could look at different things, and it creates what we call as a dynamic signature. And then it applies those dynamic signatures to shun the bad traffic out, so that your API gateway is always up and available, and the bad traffic is taken down. What I said here, the 4 steps of machine learning, stress monitoring, dynamic signatures, and attack mitigation, all of that work from layer 4, that it is the same principle that is being used for behavioral and the DOS detection or DOS detection that is being used for network-based DDoS, and as well as application-based URL code or directly exposing a particular rules on a particular API. You could make sidecar, and you can make calls to look up a particular API call is made. You could go and look up, do or an external partner, and then based on that, you could respond it back with, and so on. You could inject something that you know of. Maybe it's an IP intelligence. Maybe it is some other information that you have. Maybe it is another information where you enrich the header and then send it into your application, so that the application can make a better use of that information, and then could process that information. So these are the use cases that we have seen where customers have come back and said, hey, can you actually do these kind of corner cases for very specific business logics to be applied into the API protection. So that's where the programmability on the F5 comes in. And then finally, performance. I mean, F5 has always been known for its ability to actually deliver high-performance applications, and the same holds good for the APIs, where it could be intelligent traffic steering, load balancing of the traffic based on what kind of URI or what kind of API call is being made and so on. Certain things you can actually make use of the caching features for response caching, where it is static content that is going to be requested from the external API calls, and that is some kind of content that could actually be cached so that you don't actually overload the application, and the information could actually be sent from the cache content on the F5. Right. So these are different ways in which F5 can actually help with the increasing the performance of your API services. Now, so in summary, I mean, we saw what are the requirements for the API services. And we are now, we talked about how F5 can actually help build this kind of API services. Obviously, in this webinar, we could only talk about, or could kind of scratch the surface and talk about only a few things, but a very high level at the bullet points. So if there is an interest, please reach out to your, F5 contact that you have, or to your F5 partner, and then we could get in depth and talk about specific questions or requirements that you might have around the API, how you can deliver your API securely to your internal team or to your partners or to the external world. With that, I'm actually going into Q&A session. This was short, so you can post your questions on the Q&A chat. I can take a look at the questions, and then we can see if I can respond it online. If not, then we will get back to you right away. So I have a question on how virtual patching is performed through the WAF. So when we talk about the API services, it actually depends upon what you want to protect. Virtual patching is where you have a vulnerability in the application. In this case, it's some vulnerability that's with your API services. Let's say you have an API URL, and where, let's say, I showed you an example of let's say something like the role escalation, right? For example, somehow your developer has written a code where probably they have this API in which someone could actually post. Sorry. I think I moved ahead. Yeah, let's say you have some kind of an API in which your developer has created one of the parameters called role, and the role can accept a value out there. In this case, what you see on the screen is user. But let's say there is a vulnerability in this that someone could actually modify this role and could put it into, or could put admin into it, and then they get access, or they get admin access on the application. Now, this is where you want something that F5 should actually fix this. So that's kind of the virtual patching in this world of APIs. And if this is to be done, yes, this can be done easily. And in F5, you can go in, you can create a policy, and then say, okay, auth/sign up is my URL. On this URL, I'm going to get a JSON post being done, which will have these different parameters. And I don't want the role to actually take a value of admin, and it can take anything else. And you could virtually patch it on the F5. So your question, is it done through the WAF? It could be done through the WAF engine on the F5. It could be done through the iRole. It could be done on the access policy if that needs to be. So it depends from an API to API. But yes, F5 is highly programmable and has a lot of, it's kind of the Swiss knife to actually help you or protect your APIs against different kind of cases. Next question is, what is parameter tampering and escalation attacks? So this is one example. What you're seeing right here is where there is a parameter by the name role, and once the user is authenticated, that gets tampered, that is being tampered with. Now, sometimes I would say, if you are interested, you go into your browsers when you are accessing any of these applications. Go in, take a look at the different sessions that are available. Most of these modern application stores things which are like, say for example, have you seen this modern applications where you probably add something to your to the cart? For example, you go to a shopping site, you add something to your cart, and the page doesn't refresh or anything, right? It just adds, and you immediately see that your cart, you see one item added to it, and so on and so forth. Only when you actually do the checkout is when there is something that is actually getting posted to the application and so on. So where does that get stored? That gets stored within the browsers session, and that we have seen where there are information like even the tokens, and that could be a bad design, but authenticated tokens getting stored in this. So someone could actually tamper the parameters that are getting posted. It's very, very, very kind of synonymous with what you do with web application parameter tampering. Okay, what we used to do on the web application, where we used to actually kind of modify the code that is being sent to the application. So the same thing is where the parameters or the query or the data that is being posted to the application is tampered before it is sent to it. It could be anything. It could be tokens, where similarly how on web applications it could be cookie tampering, it could be a particular HTTP parameter tampering, and so on. Very similarly on the APIs, you could tamper with your you could tamper with the parameters and get to data that you're not supposed to. Escalation attacks are typically where you actually do where you kind of escalate your privileges or roles within that particular application, and parameter tampering is one way of doing that. Another way is kind of manipulating the tokens, and other ways of doing that. Okay. And next question, can you confirm the license requirement to have this API security? Yes, so I would say there is a license which is, it depends on what your requirements are. There are a lot of stuff that can be done. So if, say, for example, you want network DDoS protection, then yes, then you need to have the network DDoS licensing, which is to be done on the box. If it is purely payload validation, then yes, one form of license could work for it. If you want payload plus you want the authentication, then you could add both of them licenses. So I would say reach out to the F5 team. That we are very flexible in the different licensing models that we have to provide the API security. Next question, will it work as a gateway for external APIs from all applications? Yes, it can do that. The only thing that F5 doesn't do today is actually content transformations, right? It doesn't work as a middleware to actually do content transformations, where there are cases where the external world, it's actually a JSON, maybe to the backend, it's actually a SOAP. So we don't do those transformations. So that's where you will need the typical API gateways or middlewares which actually do that. F5 doesn't support that as of today. But yes, it can be someone which can be a gateway to your API for external applications. It can perform the authentication. It can protect it against any kind of attacks. It can do DDoS protection to it. It can give the bot protection to it. So all of that is something that F5 can do, except for the content transformation. Next question, what modules need to purchase to implement API security? I think I answered that. It depends upon what is it that you need in the API security. Is it just the OAuth authentication? Then it's a different license. Do you want payload validation to be done? It's a different license. If you want both of that to be combined along with DDoS and so on, so yes, that can also be done. So reach out to your F5 team, and they can probably get to you understanding your requirement and tell what is the license that needs to be purchased. If not mobile, can we use F5 for web-based applications? Of course, yes, you can. So even if you don't have mobile and you have APIs exposed over HTTP, yeah, you can definitely use the same. You can use the F5 to protect the APIs over web as well. Next question: if we have a UTM along with F5 LTM, so still we need to protect the API using security features. Okay, it depends upon which UTM box you have and what you have enabled. But to my knowledge, and this is to my, in the sense, Sudarshan's knowledge, is that none of the UTM boxes are able to do what we are talking about. All this is core to the application, knowing the application, knowing the URL, doing things like JSON content validation, doing things like authentication stuff, OAuth, and so on. And to my knowledge, I don't think any of the UTM boxes do all of this. And this is my knowledge. So I don't think it is done. Does it work with APIs used by cloud service providers like AWS, Azure, Google Cloud Platform, and so on? I didn't understand your question here, because are you asking whether you will be hosting your services or your API services on this AWS and you want all of this? Then the answer is yes, you could have your API services hosted out of this public cloud providers. And you can have an F5 in any of these public cloud providers ahead in front of your API and secure your API services there. If your question is, are these APIs available as service on any of these cloud vendors? Then no. These are to be delivered when you actually have an F5 deployed in those cloud service providers. Can we have a demo of those APIs and microservices? We can't demo the APIs and microservices. It is those modern applications that use APIs and microservices architecture. We do have an internal application, the 12-box application that I showed you. We do have an internal built application that we use for demos. So reach out to the F5 team and they could probably run a demo of that application for you to show how those applications use APIs and how it's built on a microservices platform, how it uses a MongoDB on the back end, and so on. So it could be done. Next question: how secure is to the user central bot to automate the job using any of the RPA tools? Okay, so I think this is a question that we've seen coming from most of the banks today, who actually want to use bots to do RPA or use any of the RPA tools, right? So you probably want to use bots to automate a lot of job that's being done in probably repetitive jobs like scanning of data or entering certain data and so on. So there are different ways. I don't know. We spoke about this in the Gartner Security Summit. So there are ways in which we could actually fingerprint that bot. We could actually trust that bot. There is certificates that can be certificate-based authentication that can be done with the bots. There can be token-based authentication that can be done with the bots, so that we can trust that bot that is going to make that API call to the backend application. So that's one way of doing that. So it's an interesting area that's actually being talked about by a lot of financial institutions, and keen to understand that. Would request you that you actually get in touch with the FI team, and then we can look at different options where FI can help you kind of how we can build the trust between the bot and the application, and with F5 sitting in middle. Question: what are the certification we should ask the partner to accept the API in our system? I didn't quite get the question. If you mean what is the ways in which I can actually trust a partner, the answer kind of goes back to what I was telling for the API or for the bot itself. There are different ways in which you can do that. It could be anything where you could give them an, very similarly how you use the public cloud, you can have a access code and a ID to which you can access that. You can issue them a time-based token using the F5 authentication solution to give a time-based token to them, to do certificate-based authentications. We could build an authentication form that could actually work with your environment. So we need to exactly look what is there. There are different ways in which you can authenticate your partner to let them access your APIs. And F5 could support you in that case, yeah. Can you share some examples of any big API attacks F5 resolved and lesson learned? Can't do that on a public webinar, but yes, there are web cases which have been with banks and telcos where they have exposed APIs which were not properly secured and data has been lost. So yeah, can't talk about them on RSA is something that was public, so which was well known, and so I used the example of RSA out there. Okay, any reference architecture for securing APIs of hybrid and multi-cloud? Yeah, we can. There is no one single architecture. Because it differs from customer to customer. There is no one single architecture to say how this is exactly going to be built. It also depends on what kind of business line you are, how you're going to authenticate, how the services are going to talk to each other, and so on. And we could build, obviously, all that we were talking about, which is protection of the API services, the authentication on top of it, bot protection, DDoS protection, all of that forms part of that architecture. And there is one very high-level reference architecture. I don't know if that is available on the f5.com from our marketing team, which does talk about a little bit of what are the kind of minimal security that you should have for any API that you expose. So reach out to the F5 team, and we could help you get that, or help you in building that architecture for your APIs. How can we encrypt JSON output? Okay, so if you are actually wanting, okay, this can be both ways. I would read that you are actually going to give out a JSON response and you want to encrypt that JSON response. There are different ways, and this is where the programmability comes into play. So it could be as simple as the token that has been issued. So you encrypt the JSON payload with that token, so that only that particular client can actually be able to read that JSON output. So this is something that can be done using F5 programmability. So as I said, you see how different and varied within the last 10 minutes itself, the different kind of questions that have come. So this field is like very, very dynamic. It's very difficult to put one size fits all. It's a solution you need which is highly flexible to meet different requirements. Okay, so there are a few licensing questions. I think I answered them around which specific license you need and so on. There are questions around what are MIME parameters not required to be hardened for an application? How does it can be identified? I didn't quite get your question. If you're asking whether within the request if there are MIME parameters that need to be not required for an application. Yeah, so if some parameters, MIME parameters typically don't come into the API request, but if there is something that you want some kind of a validation on any kind of headers, including the MIME parameters or something, before an API call is made, yes, that definitely can be restricted on the F5, because we have the visibility all the way from on the HTTP headers all the way to the payload API payload. So you could actually do that. What are the chances of false positives? I It depends. I mean, obviously, there is no solution that says that it is 100%. There will be no. I mean, there will be zero false positives or anything. It depends upon, because things like NoSQL injection and so on, it's actually signature based. So there could be a chance where there could be a false positive on it. Chances are less because of the way the NoSQL injection or NoSQL databases are done. It depends on how your applications actually are developed as well. So, is it possible for API from cross-site request forgery? Okay, so cross-site request forgery actually happens for when you are actually going to do post to a particular URI and you have some kind of an authentication token to go along with it. It's not, yes, CSRF is possible for any kind for even on API services as well. And yes, we could protect knowing which is the URL it is and what kind of token it should carry. So if someone forges a different token, F5 adds. There's an entire thing. You could look up YouTube, and there is a channel of F5 out there in which you could look at how F5 prevents CSRF, and pretty much the same holds for API services as well. Thank you very much. There are, I think, 10, 12 more questions out here, and we are on top of the hour. So what we will do is we'll take these questions that I couldn't answer. If your question was not answered, rest assured, maybe in a few days, you will get a response back directly from our marketing team. With that, thank you very much for your time this evening. Hope you enjoyed it was a good educational session on what we could do on in protecting our API services. Looking forward, reach out to the F5 partner or to the F5 account team, and we will get back. We will get in touch and see how we can help secure your APIs. With that, thanking you. Thanks very much. Have a good day. Good evening ahead. Thank you. Bye-bye.
Thank you, Sudarshan. Thank you all for joining. Have a good day ahead.